Well, hi, good morning, and thanks so much for joining me in my shop here. What we're looking at is the weather radar for where I live. I thought I'd just show you this because of this interesting weather phenomenon that occurs in the Great Lakes region. Now, I live right here in Aurelia, and you can see a band of snow coming across. This band of snow is called a streamer, or sometimes called lake effect snow, and it's from wind. The prevailing winds blowing across the Great Lakes, picking up moisture from open water. There's still open water, I suppose, out here, and creating these line storms that blow across. It's very common in this area. Anybody who lives in the Great Lakes region knows about these things. But we're just getting blasted here by a big one. It's dumping a lot of snow on us. I'll just back out a little bit. Whoop, a little too far. You can see sets of streamers here coming off of Lake Superior. Little action down here. You can see streamer. Look at this. You see these thin streamers out here in New York State, coming off of Lake Ontario here. But the big bad one is coming over top of us, right here. And that's going to go on probably all day. So no doubt, operating my snow blower is in my future for today. So my last video I posted came to a crashing end, literally. If you watched it, you know it just kind of went boop. And that was because the hard drive on the computer that I used to make these videos got full, and the software, the recording software, just stops. And I failed to put a proper thank you very much for watching it ending on there. Forgot about doing that, and I've put the video up with the sudden ending on it. So, no big deal, really, but that's what happened. So now we're going to carry on with the next steps in the tune-up, or alignment, if we want to use that word, process for the scope. So the next step is to calibrate the Y deflection amplifier. The Y is the vertical part of the oscilloscope. The adjustment is right here. It's this black adjustment right there, R222. The trick here is you need some kind of voltage standard to work against. The instructions say using a 1 volt calibration. It doesn't really, it sort of suggests that you should not use the calibration here on this. Well, it says calibrated output. It says right on it, 1 volt. Just looking around my shop and looking for a standard battery. There's some Mercury batteries whose voltage is accurate to a couple of decimal places. I don't have one. I used to, but I don't now. So what am I to do here? I think what I'll do is I'll check the calibration as it exists right now using this 1 volt supply. My earlier impression is that it will show up a little too large. Well, let me just get that going, and we'll see. Okay, so trying to do this with a calibrated 1 volt source, and when I don't have one, well, what am I going to do? First, I'm going to start by using the source that's right on the scope. And we'll take a look at it. And even though I have the scope sideways, the camera is going with it, so the camera's sideways, so the image you'll see is upright. Let's take a look at what's there. Oh my gosh. Let me just turn some lights on here. Well, that's not so good. What you'd like to see there is a beautiful square wave, not one with a slope in it. Now the connector I'm using right now is the simplest uncompensated connector scope. It's a scope lead or equipment lead, but I'm not so sure that that shape, the sloping line here, is really from the lead. I think it's more likely the scope's own square wave looks like that. The scope's calibration signal is not proper, but how am I supposed to know? So we're going to take this very simple lead off here, and I'm going to put on a scope lead, but really the same question is going to come up. Is the scope lead calibrated? Should I calibrate it against this square wave? Or what should I do? This is what I spent quite a bit of time on for a couple of days. So here we are using a scope lead times 1 setting. Not that that should really matter too much. And what do we get? We get another view of a sloped line. So I'm certainly not inclined to start adjusting the probe to compensate for the slope in the flat part of the line. What do you say we put this image, we put this test signal up on another scope and see what it looks like there? That sounds like an idea. Okay, let's see if I can find some certainty here. So I'm using a Tektronix scope lead. It's plugged in right here. And here's the end of it. I'm just going to clip it onto the calibrator here. Now, I'm pretty sure this is a much finer oscilloscope than the one I've been working with. And where is the output? Right there. Fortunately, this scope won't trigger, so I've got to do this sort of cheating way of doing it here. Let me turn the brightness down a little bit. Boy, oh boy, oh boy. So I spent a long time fooling with the compensation on these leads. And I thought I had this one adjusted quite well. And I'm sorry the camera's kind of low here. It'd be a lot better if it were up like this. Well, you can see that this line is curved. It's curving downwards. So the scope is not compensated properly. Scope lead. How come it's not? All that work I did is because I haven't let this scope warm up for a while. Wow. I think I'm going to do that. I think I'm going to stop for 10 minutes, let things warm up a little further. I just turned this one on. We'll see if that doesn't flatten out before I go further with it. Okay, I think that's been running long enough now. Now, compensation is about enabling the probe to work accurately at high frequencies, and this is not a high frequency. This is 1 kilohertz here. But high frequencies are contained in the sharp corners, or what should be sharp corners of the display. And now I'm just going to swing this like that. The adjustment is here. Okay, so I'm just trying to sort of flatten off the top here, or get rid of this curve. There, you can see now it's curving upwards and the screwdriver slipped out. So this actually isn't going to have an impact on the low frequency measurements that I'm using this for, but there we are. Now that looks nice and square to me. So what I believe I can do now is I can take this test lead and put it on the square wave coming out of the other unit. Now this is supposed to be 300 millivolts. Let's just make a quick check of that. We're on DC here. If I put this to 0.1, that should be 3 squares, 3 divisions. So let me just move this right on a line. This scope, the graticule is not on a plastic sheet on the front of the scope. It's right on the scope glass. In fact, it might even be inside the scope glass. I'm not sure of that though. So the parallax error is absolutely minimized on this scope. You look at it from any angle, you see the same thing. So I can see that this is still curved a bit. How did that happen? I thought I had it straightened out. live in a world where YouTube makers chop out the fractions of seconds between words where they hesitate, you know, between sentences and stuff, and they chop it out. I don't do that. That's very unnatural. So you're going to have to watch me fiddle here until I get the screwdriver in. There we go. Straight on the top and slightly curved on the bottom, which I don't quite understand. Looks very good in the camera though. Okay, good enough, because it's not going to make a bearing. Too much of a bearing. Anyway, let me hook this up to the other scope now. This is going to be a much larger signal. This is 300 millivolts. The next one is 1 volt. Go right off the screen here. Let's put this right on 1 volt. Put the ground on. Here we are. So now the idea is, if this scope is calibrated, if this calibration is calibrated, then I should be able to check the calibration of the other signal, the other calibration signal against here, and get some level of comfort. So that should be 1 division. There should be 2 division. There should be 5 divisions. 1, 2, 3, 4, 5. So you can see it's lined up here, but it's quite short up here. It's not making it to the 5th division. So the suggestion with this scope is the other guy is putting out less than what it says it is. Less than 1 volt. And I didn't see anywhere where you can adjust this calibration on the other scope. So another option I have is to use the calibration voltage here on the other scope. You know which one to believe. Do I have another way of checking this? Unfortunately, I can't just whip a voltmeter on these things. They're square waves, and the voltmeters are calibrated for sine waves. What to do? What to do? Well, how far out is this really? So if this is really, it looks to me like roughly a 1/10 below. That would be right? But it'd be half a division in 5 would be a 1/10 of a volt below. It's a little less than that on the scope actually. So it's maybe 9/20ths low. No, not 9/20ths. 3/20ths. It's a little low. Is there not an adjustment? There's a certain absurdity to having an adjustment on a standard. What to do? What to do? Back on here again. 300. So again, that should be 3. Oh my gosh, the uncalibrated light is on. What did I? Oh, for crying out loud. Okay, forget all that. Flush all that away. I must have bumped it at some point or something. Yeah, let's put this back up here. So there we are. 3. So this is really quite accurate. I've never adjusted anything on this scope. Nothing. So that's extremely reassuring that that this is correct. So let's use this on the other scope. At least maybe there's some sense to have everything calibrated the same way. And I don't, who am I? I'm splitting hairs here. I really don't care about a fraction of a volt and stuff like that. But having fun doing this. Okay, so we'll switch to the other scope. Now, next problem is having a calibrated test lead to use on this scope that you're looking at now. So when I've done my compensation of these leads, I did it all with the scope up there. So I do have a do have a dilemma here. Let's put this on and we'll see what happens. And I'll connect the ground up here somewhere. Okay, here we go. Let's take a look. It's much higher frequency. It's probable the built-in calibration for this scope is actually running at 60 cycles. We'll just up the trace speed. The great thing about this scope is it triggers perfectly well. Well, that is just beautifully straight and level, isn't it? Good. Now is it 300? 300. So I'm going to set the, that's 0.1. So we should have 3 divisions here. 3 divisions, and we'll just set it right like this. Again, there's a calibration, there's a parallax error in the camera, a slight one. So here, this should be exactly 3, 1, 2, 3, and it's slightly low. Looks like it just moved a bit. Slightly low. Okay, slightly low. So that means the vertical amplifier needs to be increased. Vertical amplification needs to be increased a touch. Why don't I do that? Because I'm right here, ready to go. Okay, so I'm going in the adjustment involved. Here we go. Okay, so let's stretch it up and down. Let me reline it up here. That's all it took. So that, in accordance with what I'm doing, is good. It's pretty good. There's definitely a parallax thing happening. So it looks like this is above the line, but it's not. It's actually on the line. It's just the camera's position is. Yeah, I'm not going to try moving it. Okay, so now what if we go back to the calibration output on the scope we're looking at right now. Okay, so I'm moving the test lead over. Now we're going to shrink this down, and it's gone way off scale somewhere. What's happened here? Oh, the frequency. Yeah, the frequency is much lower. That's what's happened. So there's that sloping line again. Now it would appear that I've adjusted the scope lead properly based on the other signal, so the from the other scope. So that suggests that this sloping line is just because of the calibrated output on this scope. Let me just move it up a little bit. Where's the other one? Okay, shrink this down. So that's 0.5. There should be 2 divisions. If I've calibrated it correctly, what will we do in a case like this with a sloped line? You put it right in the middle of the slope. And sure enough, that's right on the money there, isn't it? If you look at the middle of the sloped line, that's pretty good. Now, this is probably why I was going around a little bit in circles the other day, and I didn't post anything on YouTube. Chasing down, trying to level out that flat line. When in fact, the line is tipped on an angle because that's the nature of the signal here. Well, what happens when I look at this up on the other scope? Did I see the same slope? Okay, let's go back to the other scope. Here. Get the scope lead that I know is properly adjusted. Stick it on here. Okay, so this is supposed to be 1 volt peak to peak, and I have this set at 1 volt per division. Let's take it up to 2. Let's go here. So there should now be 5, I think, in here, and it's just a wee bit high. No parallax error. So up here, it's slightly high up here. you want to believe that scope. But I can't, so I can't change it. At least I don't know that I can change it. It's very close though. I mean, that's got to be what? That's got to be within just a few percent of what it should be. And that's probably within the range of accuracy of everything. Okay, I think I'm happy. I think that's the vertical deflection adjustment or Y amplifier adjustment done. Okay, and you got a chance to see some of the confusion with test signals, test leads, different scopes, all that stuff. Okay, so I think what we'll do now is we'll read the next section and see what's up. Okay, the next step isn't really the next step, it's to just compare the other channel to make sure it's working properly. So we'll do that. I'll just move this over here, and then we'll bring this one up. Okay, flip to the camera for that scope. So we're on the 0.1 volt. Let's try 0.2 volts, and that should give us 5 divisions. And this is the one with the parallax problem. Okay, setting it, and looking at this line down here, and you get about the middle of the slope. Okay, and looking now at this line, whoops, and it's well above here. Okay, switching back to the other channel. I'm just going to bring it up right on top of this one here. And setting it also to the 0.2. I'm looking for a difference. Okay, whoops. So I'm putting the here in the middle of the slope. And the lead keeps slipping off. Same thing, the same deal. So what's going on here? This scope is saying the 1 volt is more than 1 volt, and the other scope is saying no, it's less than 1 volt. But when I bring over the 300 millivolts, which I'm going to do now, it's all happy. That doesn't quite add up, does it? Does all that add up? Okay, let's move away this so we're not too confused. Go to 0.1, that should be 3 divisions. Okay, and we'll move it down. Well, it's right on 3 divisions. That's exactly right. Okay, well, using that, we'll go to the other channel, see if it's exactly right also. Okay, goodbye to this one, hello to this one. And we'll set this to 0.1. And it looks pretty good. Yeah, it's right on. So how did I get 2 different voltages from the Okay, I'm gonna go back to the test signal from this scope itself. 0.2 per division should be 5 divisions. Now, okay, maybe it's this middle thing, I'm not getting it very right. I can speed this up, and there's a better middle. Speed it way up and trigger it to a stop. It doesn't want to trigger now. What's the matter with you? Triggering on, oh, it's because I'm triggering on Y2 and I'm running Y1. Okay, there we are. There we are. Very good. Okay, so it should be 5 divisions. Let me set this again for the middle based on my eyeball. It's definitely above up here. So that suggests, everything suggests the scope is calibrated. The calibrated output here is not, it's slightly high. Slightly high. So now if we read the calibrated output on this scope, but read it on the other scope, slightly high, slightly high. Whoops, wrong camera. Slightly high. Slightly high. Is it slightly high? Okay, just bringing over the test lead here. Oops, there we go. So, over here we're looking at 5 divisions. Slightly high. Ever so slight. Okay, that adds up. That all adds up. That's good. Once again, overkill, but you know, if you're going to do the calibration thing, I guess you should take it to as far as you can. So that's good though. I'll be able to read some voltages. I have some, even if the machine is not, excuse me, wasn't far out of calibration. Doing this provides me a level of comfort in using it that, in fact, the results I'm seeing are calibrated. So that's good. This is a good exercise, even if in the end not a lot of change occurs with the oscilloscope. Okay, we gotta look at the next thing. What is next on the hit parade here? Okay, this step is definitely complicated. So, but it reveals something about the oscilloscope. Input capacity and attenuator compensation. Capacitors C25 and C27 are selected such that the input capacitance is approximately 28 picofarads. So what they're saying here is, as you're switching through different settings, and I think it's the volts per centimeter is the volts per centimeter settings on the 2 channels. The unit is designed to try to maintain 28 picofarads at the output connector, but it doesn't maintain it exactly. So there's some compensation that is done to try to pull it close to 28. That attenuation is done by adjusting this C202, which I can access. I've already checked it. Notice it says adjusted for a square top to the display, so that angled top is about to be fixed by this adjustment. To set the attenuator compensation, set the Y1 volts per centimeter to 0.5, input coupling to DC, time per centimeter to 0.5 milliseconds, connect a low impedance 3 volt 1 kilohertz square wave signal to the input and adjust. Now, why doesn't it rely on its own calibration output? Why doesn't it say that here? I keep suggesting you should use alternate equipment. So I don't think the voltage is all that critical. It's the slope on the line. So not knowing the state of affairs with the calibration output on the scope, I'll use the other calibration output from the other scope. Instead of 3, you know what, I can't do this because I need a larger voltage here because of this setting. And in here, repeat for Y2, equalize. So then you set it, instead of 0.5, you set it to 0.2. There's some fairly large difference going on inside the scope when you switch between 0.5 and 0.2, and then you repeat this. This time using a 10-to-1 probe, or a resistor if you wish. If you use a resistor, you got to do this. Oh my gosh, that's beyond me. Approximately 6 centimeters. Adjust the probe compensation or the trimmer for a square top. So you're matching one to the other. You're either going to match the scope to the probe or the probe to the scope. Now I got multiple probes here, which is obviously a problem. Set my, well, what am I going to do? I'm going to stop and ponder this a little bit before I do anything. Okay, so what I've chosen to do is use the square wave that's provided by this signal generator. I think I'm probably quite safe trusting it. So we'll take a look at the square wave on this scope here and the adjustment. I've got a tool ready. Just practicing here a little bit. The adjustment is right up here. Good. 202. Let's look at the screen. I should try to correct the angle of my camera here. Okay, that's a little better. Okay, so we're supposed to adjust it to flatten that. Now that's not got the same angle as that calibrated output signal had. So it says something about the calibrated output signal on that scope. Not reliable. I think I need a higher frequency here or a slower sweep. Maybe slow the sweep down. Or rather speed it up rather to give a bigger line. Well, that looks really flat to me. Looking at it really closely, I think it's tipped this way just a wee bit. Okay, of course I'm looking for an excuse to adjust it. Let me just move it up where it's not in the parallax zone of the camera. So this is about straight on to the camera here. It certainly is pretty darn straight across, isn't it? Let's adjust this anyway and see what happens. 202. Okay, I'm in. Here we go. Oh, that's what it does? I thought it was going to tip the whole angle. I guess not. If you're adjusting the capacitance of the input. Now, wait a minute. It said use a low impedance source, and that's what I've done. I think that saves this test harmless. If you used a higher impedance source, then you would have trouble doing this because the source could be causing the bend in it. So how's that look? That looks about perfect to me. Maybe it's up a little bit. Let me fiddle with it some more. And one of the things I know about myself is I love to tune things in all kinds of circumstances. No, I can't really affect the curve I'm seeing in the straight line. Okay, well that's as good as that's going to get. Now the next step is to either do the other channel. I can't remember. I'm going to take a look and see. Yeah, what it says is repeat for Y2. So let's switch to Y2 here. Okay, get rid of this one. Okay, some strange stuff here. What is that? This is a little too sensitive, and we're triggering on the wrong signal. What's happening up here? Oh, is that the other one? Yes. Okay, get that off the screen. I hit the focus by accident. You can definitely see a curve there. Okay, and where's the other part of the signal? It'll be down here. So if I go to 0.5, I'm going to make sure I'm in the right part of the range for this adjustment. So going to be, I need to check to be sure I'm not doing this wrong. 0.5. Coupling set to DC. 0.5. Coupling set to DC, yep. Around 0.5. Again, it looks really straight. Maybe there's a touch of a curve. Okay, now I'm adjusting a different adjustment. This time it's 222. And that's right in here. Just putting the tool in. There we go. Okay. Yeah, there we are. Very good. Now the next step is to repeat this, but do it in a different range on the volts per centimeter. And their suggestion was to change the probe and use the times 10 to accommodate this, but I don't think I'm going to do that. I think I'm just going to change the output level on the signal generator. So let me check quickly here what we have to do in terms of the voltage. 0.2. Just switch it to 0.2 and repeat that with two different controls. Okay, 0.2. 0.2. Okay, 0.2. So we'll stay on the Y. We'll flip to 0.2. And I'm going to reduce this output. A 10 decibel pad, and now we'll look back at what we've got here. So this is Y2 0.2. Looks pretty darn good. Maybe curved up just a touch. So now we do the other adjustment here. Uh-oh. Oh, did I just grab the wrong adjustment? I just turned it and nothing happened. 221 is what I should be adjusting. 221, just looking back at the instructions here. And adjust. 221. Why did it make no difference? I didn't follow the instructions exactly. Point 0.5, that's the speed. 0.2 is the voltage. I don't know why that didn't do anything. Why didn't that do anything? Let me adjust it wildly here. I don't like this situation when this happens. I don't like it. Okay, I'm adjusting it wildly. Nothing happening there. Definitely doing the right one. You know, it could be because of the low impedance input to the scope. Now, I really do need to use a scope probe, but the scope probe has to be compensated properly. Maybe we'll go back to the previous step, switch. I'm not using a scope probe right now. I'm using a 50 ohm test lead with BNC on both ends. Maybe I'll put the probe on, and then I have trouble picking up this signal. Okay. Okay, I gotta stop and think for a minute because something's gonna go wild here. Okay, so what I've done is I've introduced a probe, a test probe, and made no other changes to anything to see if there's any bending of this line or anything funny happening. It doesn't look like it. Looks like it's just fine, perfectly straight. So now we're supposed to switch to the times 10. Okay, so we'll go times 10. So now to get an accurate measurement here, you have to multiply by 10. What I'm going to do is I have a 10 dB pad and I'm going to take it out on the output. Okay, it's drifting because it's below the trigger level of the scope right now. When we're supposed to be on 0.2, which we are, but what if we go to 0.1? Adjust the trigger just a wee bit. Okay, so now I'm much closer to what they're saying in the manual. I have a times 10 in. I'm using a probe, and there's a curve there, a very slight curve. Let's see if adjusting this affects it now. Okay, just putting in the alignment tool here. You have to align the alignment tool up. There we are. Okay, what happens now? I don't think I'm turning it. misaligned alignment tool. That's got to be in. Okay, now watching. It's not doing a thing. Oh my gosh. This is bad. I don't like this. It's not good. Y2. Definitely everything's okay. This control, it's a capacitor, goes around and around. It's making no difference. Oh no, it doesn't go around and around. Just a second, my scope lead just popped off. It doesn't go around and around. What I've done is I've driven it down so far I can hardly engage it. Uh-oh. Driven it a long ways. There, I got it. Okay, so I'm bringing it back up, 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 up. So probably turned it around about 5 times. Nothing's happening. Now the post is way up high, so for sure I'm adjusting something here, but nothing's happening. Let's switch to the other input. Okay, I'm going to move this one out, bring the other one in. Okay, move the test probe. Make sure this is set to 0.1. This is set to the same range. You know, it's 0.1, not 0.2. Trigger it on that input. Looks perfectly straight. What happens on 0.2? Is there a chance this thing's only active on 0.2? 0.2 volts per division? Okay, so I'm trying to get a piece of that adjustment. There we are. And the tool here, what happens? On the other channel, same effect, nothing. I don't like it. I do not care for that result. What happened to the trigger? There we are. Well, I mean, it looks great on the scope, whether I'm adjusting it or not. But my concern is what I'm adjusting is doing something else, because I've done something wrong, and I've just kind of randomly readjusted those 2 last adjustments for the 2 channels, and the result is something's wrong and I don't see it yet. I'll encounter it somewhere down the road. I don't really know what else to do here. Yeah, I don't know what else to do right now. So we'll leave it like that and move on to the next thing. Just make a note in my head that something didn't quite work out here, or appears to have not worked out. So the next calibration is the actual calibrated output adjustment to make sure this is what it's supposed to be. I already know it's a little bit wrong, or at least I think it's a little bit wrong based on using the other scope, which it could be wrong. The assumption in the manual is that I have a 1 volt standard here that I can use. So I hook up the 1 volt standard, make the adjustment. Rather, hook up the 1 volt. Yeah, hook up the 1 volt standard. At this point, that should just show 1 volt on the front. I've essentially done that by using this as a standard. So really, all I should do is just make the adjustment of the calibrated output. Why is it saying hook up a 1 volt standard again? Why did it say that? Did I miss something here? Okay, we're reading over here. Set Y attenuator to 0.2 volts per centimeter, then apply to Y1 an input a 1 volt 1% square wave calibrator and note the exact deflection. Remove the square. Oh, note the exact deflection. Well, can't you adjust it a bit with? Anyway, note the deflection. Remove the square wave and apply the internal calibrator to the Y input, and then adjust it to give it the same deflection. Well, Isn't that a little tricky to do when you don't have a calibrator? So why would I not just right, I'm adjusting the calibration. Blah 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 blah. This is going to be a little tricky to do. Yeah, the calibration voltage is 300 millivolts. And that's a bit of an odd number. I wish it was 500 millivolts. That'd be a lot easier. Or 100 millivolts. I picked 300. It's just not lining up easy on here. Okay, I'm going to stop and ponder, but I don't think I got many options here. Okay, so what I've decided to do is use this scope to calibrate the output of this to 1 volt, square wave, peak to peak, and then just move the output onto this scope and see where the 1 volt peak to peak shows up. It should be calibrated now anyway. It should show up where it should show up. Then switch to this calibrated, or let's say at this point uncalibrated output, and then calibrate to match. And in the worst case scenario, I've got 2 scopes that are both off, but off in the same way. Again, we're splitting hairs here. I think this is a real refinement, but let's see what happens. So where are we here? So we're looking at 0.5 volts per division. So we're looking at like 1 volt should be down here. So we're way high. So I'm just going to put in a 10 dB pad. Very close now. Let me switch to that camera. I can't. That camera's not available right now, so that's okay. So I'm just going to adjust this until it's 1 volt. Come on over here. This is better. This will do it. Look at that. It's close to lunchtime already. Oh my gosh. Okay, so I can vary the amplitude here quite easily. And you know, if I could just turn the light up, scale illumination here, just a little bit. Help me a touch. Okay, let's center this the easy way. Okay. Okay, that's good enough. Bring this down. Not quite centered. Okay, so I would say that's exactly 1 volt peak to peak. If that were the case, then moving this should be 5 divisions. Let me just reposition it so it's on the start. 1, 2, 3, 4, 5 exactly. Okay, I think we're good. 5. So we have 1 volt peak to peak on the end of this cable. I'm going to grab it. I'm going to stick it right in here. Now this is to get a display on the screen of what 1 volt looks like. It seems to me this should be a calibrated thing. Yeah, look at that, right on. What are we on? We're on 0.2 volts per centimeter, and it's 1, 2, 3, 4, 5. Yeah, right on. Excellent. Okay, so now I'm going to switch. So what you see on the screen is actually the calibrated, the uncalibrated calibrated output of this signal generator. I'm going to do it with a simple clip lead type deal here, simply because I can clip it on. Okay. What the heck happened there? So maybe going too fast. And I guess there's some DC involved here somewhere along the line. So we're going to reposition this right on the bottom here. Now there's parallax on this one, so I'm going to get right down here. So touch high. It's a touch high, just like you see it in the camera. Okay, now the adjustment is R304 set calibration. R304 is easily accessible. I already checked that. Now, 304 would be this one. Let me just, I want to read it right on the board. Set calibration, right there. Get the screwdriver in. I didn't have you do this earlier, but there it is. That was all there is to it. Happy scope. Okay, looking just the parallax problem here. It's still a touch high, but we're certainly within the range of a few percent. Okay, here we go. Just a little bit further. Like that. Okay, looking again. Still just a touch high. So what I'm doing is I'm just aligning my eyes directly to make sure there's no parallax. Get down a little bit, right there. A little bit more, just a little bit more. Now it doesn't look right on the camera because of the parallax. It looks too low. We're still a little bit too high. There. Yeah. So I'm setting the lower line right on. Upper line's still just a touch too high. Is it readjusting itself? What's it doing here every time I keep... Okay, that was quite a bit that time. So we're lined up on the bottom. Dead on. We're dead on. Even though it doesn't look that way in the camera. It's just because of the angle of the camera view. If I pull the camera back a long ways, parallax would be minimized, but you wouldn't be able to see anything from that distance. So so now the calibrated output is really calibrated. That's great. Now what if we take that calibrated output and put it on the other scope? As we'll take the risk of just spoiling the whole experience here, but let's try it. So we want to take the calibrated output from here, the now calibrated output. I need to put a ground connection here. And we'll zoom this up onto the other oscilloscope. Zoom it up there. Oh, that clock is screaming it's lunchtime. Okay, we're on. We're on 0.2 volts. Let's move it down. There it is. 0.2 volts. And again, I don't have this camera's not operating right now. So I'm just going to do this with my eye. Bang on. It's bang on. But of course, it's kind of a circular calibration thing I'm doing. So they are happy together. Excellent. That's great. Wonder what's next. Okay, so the next step is quite involved, and I think I've had enough for today. If I go too far, you know what, I'm going to start making mistakes and stuff like that. So I want to thank you very much for watching these videos. It's very helpful to me, in fact, because from my point of view, what's happening is I'm being supervised while I do this work. And in all honesty, if I wasn't making videos and I was just in here doing this myself, I would do a sloppy, fast job of it. And the result probably wouldn't be all that great. And, you know, that's me. Supervision. Supervision and accountability is good for all of us. be happy if you are supervised, especially supervised by somebody of some quality. That's you. You're the person of quality here. And people who duck supervision or duck accountability for their actions are people you should not involve yourself with. That's what I say. So there we go. So tomorrow I'll continue on. It looks like there's at least another hour's worth of work here in doing more calibration. They're getting more complicated. Each step of the way is getting more complicated, of course. So thanks a lot again for watching, and see you tomorrow as I carry on with this.